The goal of the first level screening process is to reality check the list of potential sites identified during the preliminary site identification phase in order to determine which ones are most suitable for a community microgrid, or in some cases a group of community microgrids, and how they might be clustered into optimized microgrid configurations. The first level screening process involves 4 interrelated activities. First, mapping all the potential sites identified during the preliminary site identification phase, collecting critical data on these facilities, identifying potential facility clusters, and assessing the overall feasibility, leading to a go, no-go decision phase. If the preliminary indications are good, the project is a go to move on to the next phases of planning. If the preliminary indications are not a slam dunk, it may be a no-go, or further review, probably with professional assistance, may be warranted. To start off the first level screening process, it's important to map the updated list of facilities/sites developed during the preliminary site identification phase in as much detail as possible. There are many options for how this can be done, varying according to mapping level expertise and the degree of detail desired. Options include Google Earth, various geographic information system technologies, or any other mapping software that the staff or user is familiar with. GIS is any system for capturing, storing, checking, and displaying data related to positions on the Earth's surface. One of the most useful features of GIS, as it relates to microgrid planning, is that it allows the user to create multiple layers on the map that can be turned on or off, and each layer can include a specific category of facilities, such as nursing homes, schools, etc., or other data that the user wants to display. Google Earth is not as sophisticated as most GIS software, but has some of the same capabilities and can be much easier to understand and use. Pictured here are the 23 preliminary sites identified for the Neptune microgrid. The names of each facility or complex have been included, and each site has been preliminarily classified according to 4 general categories: emergency, schools, public, and private. The map was generated using Google Earth, and the categories chosen are a very general first cut, mostly to help the internal stakeholders better visualize where certain types of facilities are located. Different categories can be used and may vary according to the specific needs of the municipality where the microgrid is located. This is a view of the same Neptune map, but zoomed in on the town core. The facilities can be tagged with a variety of other categories of information, as we will see later in the planning process. At this stage, the list of facilities generated earlier in the planning process needs to be analyzed in order to classify these facilities in terms of their FEMA risk categories. FEMA classifies groups of building occupancies in terms of hazard risk, based on the facility's importance to the community. These categories are important because they can help jurisdictions identify those facilities that are essential to the ongoing operation and well-being of their communities, and to rank them in terms of their overall criticality. To increase community resilience, a certain number of critical facilities should be included in any microgrid development plan. Category 1 includes buildings and other structures whose failure would represent a low hazard to human life. Category 2 includes all buildings not specifically included in other categories. Category 3 includes buildings and other structures that represent a substantial hazard to human life in the event of a failure. And Category 4 includes essential facilities, such as hospitals, fire and police stations, etc. The table on the next slide explains each category further. As noted on the previous slide, Category 1 is the lowest tier and includes agricultural facilities and minor storage. Category 2 includes buildings that are not in Category 1, 3, or 4. Category 3 is one of the critical categories and includes public buildings, schools, daycare facilities, power generating stations, water treatment facilities, and wastewater treatment facilities. It comprises the largest category within the FEMA characterizations. Category 4, the most critical tier, includes hospitals, fire, rescue, ambulance, police stations, designated emergency communications centers, and structures containing highly toxic chemicals. As each facility is being classified according to the FEMA categories, it should be noted in the master spreadsheet. This slide shows the master spreadsheet for Neptune, with the FEMA categories assigned to the 23 potential sites that were identified in the preliminary site identification phase. As can be seen, the majority of the potential sites are either Category 3, 10 sites, or Category 4, 6 sites. This is good from a resilience standpoint, meaning that a large number of the sites that would be served by Neptune's community microgrid could continue to provide essential services to the community and to other stakeholders, such as evacuees from the shore beaches, in the event of a disaster or a sustained power outage. Once the FEMA categories have been assigned, it is helpful to tag each site on the map according to its specific category, as a means to help everyone on the planning team more easily visualize where logical clusters of high category facilities are located. The version of the map on this slide shows the 23 facilities on Neptune's master spreadsheet and their respective FEMA category designations. This is a zoomed-in view of central Neptune with the core group of potential sites and their FEMA categories. Now it's time to collect data on the total square footage of each facility identified on the master spreadsheet. Knowing the size of these facilities is useful in its own right, but it's also a critical piece of information when assessing the current energy usage of a potential site for the microgrid. There are many ways to find the square footage of a facility, each with varying accuracy. Ideally, an energy audit has been done recently at the facility, because the audit will not only include square footage data, but should also include energy usage estimations. In New Jersey, any prior energy audits can be found at the New Jersey Clean Energy Program website. The next method that can be used to obtain square footage is by gathering data from tax records, using the New Jersey Association of County Tax Boards information. A third method involves using the area tools on Google Earth, and a last method is to use Google directly or another search engine to find data on the facility's website, real estate websites, or a different source. Whatever square footage calculation method is used, the final results for each facility should be added to the master spreadsheet. As can be seen in this table, this was done for all 23 Neptune facilities identified during the preliminary site identification phase. The next step in the process is to collect energy use information for all the facilities on the list. There are three key strategies for accomplishing this. Collect utility data directly from the facility, access energy audit information, or estimate energy use using the Commercial Buildings Energy Consumption Survey, or CBEX, database. The preferred approach is to collect utility data directly from the critical facilities that have been identified, typically in the form of the last 12 to 24 months of electric and gas or oil bills. This process usually involves contacting the facility and requesting that they provide the data on some type of survey form. The example shown here is the intake form that was used to obtain data on facilities in Neptune as part of their microgrid development planning process. As noted earlier, a detailed energy audit is also a great way to obtain information on the electric and thermal energy use at a specific facility. This slide shows a representative sample of the type of electric and natural gas energy consumption data generated by an energy audit. In this case, the audit covered 4 buildings in Neptune, all of which might be candidates for inclusion in a community microgrid. This audit was completed in 2010 and would need to be updated to provide accurate data for inclusion in a final microgrid development plan, but may be useful at this stage to provide a solid ballpark estimate of energy use at these facilities. And if energy use data cannot be obtained from a recent audit or directly from the facility, which can often be the case in the early stages of the microgrid development process, usage can be estimated based on the facility square footage combined with data from the U.S. Energy Information Administration's Commercial Buildings Energy Survey, or CBEX, database. CBEX data is relatively generalized, but can be sufficient for the types of high-level, early-stage energy use estimates used in the microgrid planning process. As noted earlier, ultimately, these rough estimates will need to be updated with real-time energy data, at least for the final set of facilities selected for the microgrid. To generate this type of early estimate, 3 steps need to be followed. First, determine the facility's principal building activity type as defined by CBEX on their website. Next, multiply the square footage information for the facility by the number in the MMBTU per square foot column found in the CBEX database. The table shown here is a compilation of this type of data for the most common building types included in most community microgrids. By way of example for this calculation, for a 100,000 square foot school, the calculation would be 100,000 square feet times 0.0688, which equals 6,880 MMBTUs per year. Okay, so what exactly does MMBTU mean, and why do we use it to estimate energy usage? The energy that buildings consume typically includes both electricity and the gas or oil used for heating. To generate one number that includes both forms of energy usage, the electricity use can be converted to BTUs per square foot, or British thermal units per square foot, the same unit used to measure heat energy. Combining the electric energy usage, now in BTUs per square foot, with the heating energy usage already in BTUs per square foot, we can generate a combined energy use value in BTUs per square foot that can be used to compare energy consumption across a range of facility types. This consumption is typically aggregated into annual energy usage amounts that are expressed as MMBTUs per year, where each MMBTU equals 1 million BTUs. Once a facility's energy use has been either collected, accessed from an energy audit, or estimated, it should be added to the master spreadsheet, creating master spreadsheet version 2.0. Here the estimated energy usage amounts have been added to Neptune's master spreadsheet, completing all the fields and indicating that the preliminary data collection phase is now complete, and it is time to proceed to the initial area selection or cluster identification phase. Area selection begins by combining the information contained on the master spreadsheet with the information depicted on the map. A good rule of thumb to start the process is to identify areas where at least 2 FEMA Category 3 or 4 facilities are located within a half-mile of each other and within a half-mile of a large energy user, preferably one consuming 90 MMBTUs per year or more. FEMA Categories 3 and 4 help identify critical facilities that will be essential to a community during times when the main electrical grid is down. And generally, the more of these facilities that can be served by a microgrid, the better. Large energy users help drive the technical feasibility and economic viability of a microgrid. They are typically substantial facilities, like hospitals, that will likely remain within the community for the long term. They also consume large amounts of energy on a relatively constant basis, ideally 24/7. Large facilities are important in part because the larger generators associated with these facilities tend to be more efficient than smaller ones, so they can provide power more efficiently to the microgrid as a whole. In addition, it is easier and much more cost-effective to expand these generators to provide additional power than it is to provide new generators at multiple individual locations across the microgrid. It is for these reasons that larger facilities with larger and more constant energy demands are usually included in a community microgrid. Because of their importance, they are often referred to as anchor facilities during the microgrid planning process. Pictured here is Neptune's Jersey Shore University Medical Center, a Category 4 facility with the highest annual energy consumption of any facility on the master spreadsheet, an obvious candidate for an anchor site in the Neptune microgrid. Of all the maps generated so far in the planning process, the FEMA category site map is probably the most useful at this stage for identifying suitable areas for a potential microgrid. Even on a very first cursory look at this FEMA category map for Neptune, we can already see that the Jersey Shore University Medical Center seems to be located relatively close to the majority of potential sites identified on the master spreadsheet, further reinforcing its potential as a possible anchor site. If we draw a 1/2 mile radius around the medical center, we can confirm that it captures a wide number of the potential sites that have been identified, including 2 Category 4 facilities, the Neptune Municipal Building Complex and the EMS Training Center, as well as a number of Category 3s, Neptune's High School and Middle School, the Housing Authority, and the Neptune Senior Citizen Center. In fact, if we zoom in closer and limit the radius to just a quarter of a mile, there are still a significant number of critical facilities in close proximity to the medical center, including the municipal building complex, the EMS training center, the housing authority, and the senior citizen center. Clearly, a microgrid anchored by the medical center represents at least one promising area for a potential microgrid in Neptune and is worthy of further investigation. As is clear from the previous several slides, the area selection analysis for Neptune identified at least one area centered on the medical center that meets and actually significantly exceeds the minimum criteria for further explanation. That is, at least 2 Category 3 or 4 facilities and a major energy user that can serve as an anchor within a radius of 0.5 miles. Some communities, however, may not be able to meet these criteria. If this is the case, the community would likely not be a suitable candidate for a microgrid, at least based on a first-level screening like the one we have described. That said, there may be other scenarios and strategies that could make a microgrid feasible in these locations, but more sophisticated, in-depth analysis will be needed to generate these scenarios. For example, even if there is no single high-energy user in a potential cluster area, multiple medium energy users may make a microgrid feasible if they can be cost-effectively deployed and linked together. In another example, 2 desirable facilities farther than a half-mile apart may still be able to be included in the same microgrid if, for example, the road between them is scheduled to be repaved, and the infrastructure for a microgrid can be laid concurrently with the repaving, reducing overall costs. In these cases, and in others where the municipality might be unsure whether a microgrid makes sense based on the first-level screening, professional advice from a consultant can be obtained in order to make a judgment based on local factors and contextual information.